Hi, this video is about speed and how we measure speed in physics. Since moving objects are usually changing their speeds throughout their motion, physicists have two categories for measuring speed. One is called instantaneous speed, and this speed is the speed at any given instant. Think of a speedometer. It tells you how fast you're going in that instant or in that moment of time. The other kind of speed that physicists use is called average speed. And the average speed is simply the average of all of the instantaneous speeds in an object's motion, or you could also find it with the ratio of the total distance to the total time traveled. So an example here is a car that's traveling across town, but it's having to stop a bunch of times. So it's constantly speeding up and slowing down. Its speed, instantaneous speed, is always changing. But if you wanted to know how fast on average the car went, you could take the total distance, let's say 30 miles, and the total time, 2 hours, find the ratio of distance to time, 30 over 2, that would be an average speed of 15 miles per hour. So now that we've talked about the different categories for speed, let's define speed and velocity. So speed, as you probably know, is how fast an object is moving. In physics, speed is a scalar quantity. Direction is not included. And so we use an equation for the speed down here. I'll get to that in a second. Let's come back to that. For velocity, velocity is another word you might be familiar with, but in physics, we've taken that word and we've given it a special meaning. It's speed, how fast you're going, and in what direction are you going. So it's essentially just the speed of an object and the direction that it's moving. This is a vector quantity, and so that means the direction is included in the velocity measurement. So the average velocity equation, the way we find that is the displacement of the object divided by the time that the object travels. How far is it out of place, and how long did it take to get there? Doing that gives you the average velocity. We use a V. Usually you write it as like a cursive or a script V with a little harpoon symbol above it to show that it's a vector. And we write the little subscript AVE just to signify that this is the average velocity. Now, because we're keeping with a pattern of vector and scalar, we're actually going to keep this V for velocity. It's a little confusing. And we're going to use that same symbol over here for speed. We're not going to use S, we're going to use the V, but all we do is we remove the vector symbol above the V. So we're showing that this is the same measurement, only this is not including the direction, and this one is. And so that's why these two equations look like this. All right, so just to reiterate speed and how it works, if you're going at a high speed, that would mean that your displacement or your distance that you travel is very high, and or your time that you're traveling is very small. So you have a big distance that you're covering in a short amount of time. A low speed would be a small distance covered, but a large amount of time. So it takes a long time for you to do that traveling. The velocity gets a little tricky because let's say you have a can of soda here, and you shake the can up and down, right? Shake it up and down a bunch of times, back and forth, right? And then you stop. Okay, all that motion just then resulted in an average velocity of 0. And that's because if the motion results in no actual change of position, meaning it returns back to where it started, it goes up and down a bunch, but it ends up back where it started, there's no displacement. It hasn't moved out of place at all. And so no displacement means there's no average velocity. Now, I have heard that if you flick the cap of a soda before opening it, then it calms it down. I'm going to test that out here. I've actually never done it. I've heard it. I've seen people do it, but hey. Oh, okay. We're good. Yes. I switched to Sam's Choice. You know, the economy. Okay. So one last little whiteboard here. Let's look at an example of a car moving. Here's my beautiful car that I've drawn. It's moving to the left here, as shown. at a speed of 55 miles per hour. So that's an instantaneous speed. It's currently moving at that 55 miles an hour of speed. The instantaneous velocity, we would write that. The only difference here is we add the direction. And so we say it's moving to the left, or maybe it's moving west or south. And so we signify that direction with either a negative sign, so it's moving at a velocity of negative 55 miles per hour, or we would say 55 miles per hour west, for example. So that's all I've got for you in this video. So remember, everything you have is a gift.